So now that you've seen what Java futures are, classic Java 5 futures, we will now turn our attention to the newfangled way of doing this with the Java Completable Futures framework, which is way, way, way cooler than the classic Java futures, as you will soon discover. So what we're going to talk about here is basically the structure and the functionality of the Java Completable Futures framework, just to give you an overview, and then we'll talk about how the framework addresses the limitations with Java futures, and then we'll go through the framework in a great amount of detail. So Java's Completable Future framework is essentially an asynchronous concurrent programming model that maps nicely onto key principles from the reactive manifesto, from the reactive programming paradigm. So as we'll see, it's responsive, resilient, elastic, and message-driven. And basically what it allows you to do is it allows you to support dependent actions that are triggered or called when earlier asynchronous operations complete. So this is one of those things, if you've ever programmed with JavaScript's futures mechanism, this will be very obvious. If you've never programmed with this stuff, it's like, what the heck is that all about? So we'll talk about it, and I'll show you a lot of examples. One of the cool examples that I'll talk about, and you'll get a chance to implement, is a web crawler that uses this approach. And first, let me just give you the high-level perspective from a data flow diagram, and then we'll start moving down a little bit into how the code actually works. So as you can see, this particular web crawler has 4 primary tasks. The first task is to get the start page, first page you want to begin to browse, asynchronously. So that's task 1. We asynchronously get the start page. And then there's 2 other tasks, task 2 and task 3, that depend upon successfully getting the start page, which was invoked asynchronously. So clearly, tasks 2 and 3 shouldn't start to run until task 1 completes. So that's what we mean by dependent action. So when task 1 completes, then we can have task 2 and task 3 go off and run in parallel. So task 2 will count the number of images on the page asynchronously, and task number 3 will recursively traverse the page and count all the pages that are reachable via hyperlinks on this page. So you can see we're doing 2 things. We're counting the number of images on a given page, and then we're recursively crawling to go find all the other counts of all the images reachable from that page. And then the final task, task 4, is going to wait until task 2 and task 3 are done, and then it'll combine the results and give the total. So obviously, task 4 can't run until both task 2 and task 3 are finished. So that's an example of dependent actions. Task 2 and task 3 depend on task 1. Task 4 depends on task 2 and task 3. And we want those tasks to automatically begin to execute as the previous tasks complete. Well, now let's take a look at what the code actually looks like. And this is obviously sanitized heavily to make it fit on one page. So I came up with a little bit of nomenclature to make it simple. It's kind of pseudocode, but it'll get the point across. So here's task 1. Task 1 is going to call a factory method called supply async, which is part of the Completable Futures framework. And that will asynchronously go and get the start page. So it'll download the HTML from some root URL. And what supply async returns is a completable future. And completable future, I show it in these angle brackets, kind of like the table tent numbers we talked about before. So let's assume that you call supply async, you immediately get back a completable future, which represents the completion of that task when it's done. And this will go off and run in the background somewhere in a pool of threads. Now we have task 2 and task 3. So as you can see here, task 2 and task 3 both depend on this future, this completable future, completing before they can do their operations. So those are examples of dependent actions. And so when the completable future is finished, when we're done with task 1, then both task 2 and task 3 can go ahead and start to do their thing. And what task 2 is going to do is it's going to asynchronously count the number of images on the page, and task 3 is going to asynchronously crawl all the hyperlinks on that page. And both task 2 and task 3 return a completable future to a number, which is the count of images on that page and images reachable from that page. And then task 4 is going to take image num1, which is the completable future from task 2, and im num2, which is the completable future for task 3. And when both of these complete, it will then combine the results and sum them up. So that's showing you kind of visually with some pseudocode-like approach how this gets applied in the Java Completable Futures framework. And all the things I've highlighted in red, supply async, then apply async, then compose async, then apply, then combine, those are all methods defined on the Completable Future framework. And they allow you to fork, and then chain, and then join the results. So these are asynchronous operations that are forked, chained, and joined. Gavin. Yeah, great question. So the question is, how does a task that depends on another task know that it's done? The framework will arrange to invoke the so-called completion stage method. Like when task 1's completable future is triggered, when it's complete, that will automatically cause these other operations to run, the things that depend on it. But those operations are passive until that starts. So they don't sit there and poll. It's all done reactively. When something finishes, then the framework goes, aha, this thing's done. These completable future completion stage methods depend on those things. So you basically have like a little graph of dependencies, and the framework will arrange to call it back. And so that's one of the things that makes it so efficient, is that you don't have to sit there and put timed waits or block. There's no blocking. It's all triggered reactively when something is finished, which is very cool. Something else that's very cool is you can have these operations run in parallel or concurrently in thread pools, and you can either use the common fork join pool, you can use a dedicated pool, or you can have other user-designated pools or other pools that come out of off the shelf, like fixed size thread pool or cached thread pool, whatever. You can decide what kind of thread pool you want. And that's in contrast, of course, to the parallel streams framework that kind of shoehorns you into the common fork join pool. This gives you more flexibility. Another cool thing about this, and we'll see this later, we won't see this probably till next week, or maybe even the week after, you can combine completable futures, Java sequential streams, and functional programming features to come up with some really cool solutions. And you'll get a chance to play around with that in your program at some point, your assignment number 4. Another really cool thing about completable futures, much like with parallel streams, is that you don't have to worry about locking most of the time. You don't have to worry about spawning threads or thread operations. All this stuff is done magically for you by the Completable Futures framework, and that will therefore alleviate a bunch of accidental and inherent complexities of concurrent programming, because those error-prone operations are handled for you under the hood. Most of the time, if you need locks, you can get them out of the Java class library. If you need to access I/O, the locks are already done. You could use concurrent hash map or some other concurrent collection. So you typically don't have to have any locking in your program whatsoever. And that's also not unlike parallel streams. So that was a quick overview of the Java Completable Futures framework. Of course, we're going to go through this in much more detail and talk about all those different methods, the factory methods and the completion stage methods and so on. But I want you to have the big picture view, because we're about to talk about how the Completable Futures framework fixes the limitations with Java futures.